begin on, not going to do each one of these, but just in general. Okay. So subtracting fractions, always think about this as reducing a fraction, but backwards. So we understand that we need a common denominator of 6. So it's like 4 over 6, or 1 over 6 equals 2 over 3. So what we need to put here, so it reduces 2 over 3 to 4. So it's like reducing, but backwards. 4 over 6 reduces 2 over 3. 1/2 is the same as 3 over 6. 3 is half of 6. 1 is half of 2. Of course, understand with adding negative is the same as subtraction. Just get answer 1/6. So of course, the denominators are always the same. We got fractions. Now, most of you, my guess is you went to common denominators here. I want to throw out an alternate method and see if you like it. Think about a number line starting at 0. The first number says go to -7. So go to -7. And to the left, there's -7. And this says, okay, go -1 more. Go another half. So where are we at right now? What number is this? -7.5. So whenever you have the same sign, you got a whole number and a fraction. Well, -7 minus a half is simply -7.5. Okay. Yeah. So you can do it this way and then just convert it to the improper fraction. We get the same answer if it changes to -14 over 2 and subtract. And just throwing that out there. Same thing over here. -2 minus 3/5 is -2 there. Which is -13. And of course, it works if they're both positive as well. So if you have 4 plus 4/7, that's the same as 4/7. 28 plus 4 is 13. So that might be a handy tool to use every now and then. Okay, let's next look at the review questions from last simplifying. All different types of ways that we need to check for simplifying. Always starts with factoring. Remember, we cannot cancel, we can only cancel things being multiplied. So if I have like 6 times 3 over 2, it's multiplying, then I can cancel 3 goes into 6 3 times, but it's 6 plus 3 over 2, we cannot. The idea that there's addition following any number means you cannot cancel. Same thing here, like there's following the 6 and the x is a minus sign, which means you cannot cancel that 6, you can't cancel it 2. You have to have multiplication. Luckily, we got this process called factoring that changes the addition subtraction into multiplication. So factor it. So here we can factor 2 out, DCF. And now you do have multiplication. Now it's 2 times, which means you cancel it either a 2 or a 3x minus 1. So we have, at the bottom we can factor into 2 times 4. See? And then just the x squared. And I do that just to illustrate that the same thing on the top and bottom cancel. So our final answer is just 3x times 1. And it's important to know, why can we not cancel anything else out? Why can we not cancel the x's? Again, it goes back to this. Have addition, think about that. So look to cancel DCFs. Also look to cancel both factors to see if we look at everything. So what's the DCF here? What cancels? Yeah. So strategically gave you a lot of problems where you really have to know GCFs. I don't want you looking at 12 and 24 and saying, oh, 6 goes into both of them. It has to be 12. You gotta always be looking for a bigger number. And of course, the variables as well. Gotcha. Sure. What's left over? Let's write that in. We have like n plus 2. And then we can start working on this. So what cancels here? Right. Say again? 1n plus 2? Yeah. The one's not necessary.
3m. 3m.
3m?
No, 4. Oh yeah, 6m.
Okay, so yeah, moving on. Sure. So what goes on 30 and 12?
6m.
The biggest number is 6. Yeah. And the way you guys are you're probably not writing this down, but this is what you're thinking is that, well, 30 is 6 times 5, 12 is 6 times 2. This step is optional. And as you can see, that equals 1, this equals 1, and what's left over is 5.
Why does it 5m and 2m cancel?
5m.
So it's just that.
Whatever is exactly the same. Multiplication, those can cancel out. Anything being multiplied, both top and bottom. Multiply them both sides. So, here. Now, what you guys go and do 6 and 8. Should have both there. What do we get on the rate?
N plus 4.
N plus 4, okay. Does n minus 10 cancel? So, very important. On all of these, always go back to this. The last thing you do is simplify. This is the equivalent of reducing like 8 over 12. And you have to divide both top and bottom by 4 and get 2 over 3. Well, we're doing this with all variables and everything. But that's always, in the 5th grade, that was the last step you always had to do, is reduce. Never ask anybody, well, do I have to reduce? Should I reduce? You always do it no matter what, at the end. So that's what we're doing here. It's just the equivalent because we have variables and things like that. Only things being multiplied. And technically what we did here, if I was to show the work, it would be 8 is 4 times 2, 12 is 4 times 3, and that's why our answer is 2 over 3. Because 4 over 4 equals 1. 1 times 2 over 3 is 2 over 3. You can do the exact same thing here, just with all the variables. So recall, after you, on the rest of this, it's all adding and subtracting. But once you've added it all together, you have to do all of this. Factor, and then see if anything cancels. Sometimes it will, sometimes it won't. Let's go through. So I know that the denominators stay the same when I'm adding subtraction. Okay. So the process here is going to be very similar to Common Cat. Not too difficult, right? You know the denominators stay the same. It's going to be details. And I'm going to try to catch you making mistakes on a lot of these. So you're aware of them so you don't go home and do the same mistakes. Alright, so go ahead and at the top, see what you get. Add, simplify both tops, see what you get. Again, write something down. Don't wait for me to show you what the answer is, but write it down. See if you know it. You got to test yourself. See if you understand it. Take a chance and see how it goes. The worst thing you could do is sit there, wait, I'm not going to think, and just copy it down later like after that's
Copy on
okay? So see what you get. Some down on top. Okay. Some down for the top. And what do we have?
5u plus 5v.
5u plus 5v. 5u plus 5v. Good. How do we get 5u and 5v? Well, I have 4u and I have one more, that's 5. I have 4v and I have one more, that's 5. So that's how I get that. Now, is that a completed answer?
No.
No. So if you stop right there and said, look, I'm done. This is the little things I'm talking about. We don't want to stop there and say, I'm done. Not finished, not complete. What else can I do here? So then the last step is always
Simplify.
simplify. If you have 6x minus 2, better factor out a 2, see if it cancels. So same thing here. We have a 5 right here. We have 5 on both of them. Make sure you factor that out and see if it cancels. And this is where most people fall off. They want to stop right here and say, well, I did something, so I'm done. And not continue all the way. Now, on this one, does anything cancel?
Yes.
No.
No. 5 over 18 doesn't cancel. I can't cancel out the b's, but I still need a factor to see if something does cancel. The only way you know for sure if it cancels is if it's factored. Like this, maybe it does, maybe it doesn't. Notice how we did not cancel a b out. This is plus b. This is times b. Does not work. 5 over 18 does not reduce. But your final answer must be this, not this. These are the little things that will make the life easier, like factor. Let's try 11. Give it a shot. This time now hopefully if you didn't have the right answer, the full answer last time, this time try to make sure you go all the way through. Don't stop after you simplify one time, but go all the way. If possible. Good. Similar to the U and V problem, 5x and 1x, that makes 6x. Is that finished? Yes, no? No, not finished. What can be done? Should I start canceling stuff? No, fine. Do not start canceling stuff. Why not? There's nothing being multiplied on top here. All I have is addition. Nothing can be canceled. So how do I go and get multiplication? Factor. So back to the top. What factors out?
3.
6 and 3. Factor out of 3. And now on the bottom, I'm going to rewrite, instead of 12, I'm going to write 3 times 4. Now what can cancel?
3.
3. That's 3 times on top, 3 times on bottom. There you go. How many people got that? About half? Okay. So, again, I want you to make these mistakes now, learn from them, and then when you do the even for your homework, you won't be making mistakes. I don't want you going here and saying, look, I'm done, boxing it. You come tomorrow with almost no work shown, and you're going to see everybody else with a lot of work, a lot of things canceling, and you'll be like, well, I did only one thing for each problem, so I guess those are all wrong. Yeah, so you have to be careful. All right. Also, point out how careful you have to be to know when to stop. It might be tempting to say, oh, there's 2 over 4. Don't those cancel? No. Here's a y and a y. Don't those cancel? No. We have to know actually when to continue and when to stop. All right. Keep on rolling down here. I know the bottom's going to be the same. Nice thing about having a common denominator. This is what's going to change tomorrow, by the way. We will not have a common denominator. All right. On the top, we get 4a minus a. So we get 3a, right? Negative 5b and positive 3b. Negative 2b. You agree with this? Is this right? So far, good? Yeah. Yes?
Yeah, sure.
Yes? Yes? I don't believe you that. No?
Wouldn't it be a negative?
Isn't the what? 4a minus a. 4a minus a is 3a. And negative 5b and plus 3b is negative 2, right?
Yeah.
No?
No.
What should it be?
Wouldn't it be transfer the negative and a positive?
Negative what?
Negative 8b.
Negative 8? Some people are saying negative 8. How come negative 8?
Because it's a negative cancel out the positive, so it'd be negative 5b minus 3b.
Negative
equals
5
negative 8b.
minus 3. Negative 5 minus 3 is negative 8. So you see how easy everybody's like, oh, yeah, that's right. Yeah, negative 5 plus 3, that's negative 2. And this is how you convince yourself this is so easy and you don't have to be careful. So if that caught your attention, please do not try to go off and do every problem after this real fast and then realize in the class you just did a lot of things wrong and now you have no idea how to fix it. So oversimplifying these problems gets you in trouble. Saying this is so easy, I don't need to even follow along because there's no way I can make mistakes, that gets you in trouble. So if that didn't wake you up, I don't know what will. Stick with us, don't move faster, don't say there's no way I make mistakes. You gotta let that go and say, okay, lots of stuff didn't go wrong, let me make sure I know it all. Can I factor anything here? 3 and 8? No. A and B? No. So yeah, nothing's canceling here, that's it. Well, sometimes you can factor and cancel, sometimes not. But yeah, big wake-up call. And this is one of those more common mistakes that we see is that this, when it's a subtraction, it's kind of like sugar bombing. You have to use it to teach. All right. Let's keep practicing. Try 15 on your own. Now that we're aware of this when subtraction, what we gotta watch out for. Try it on your own. See what you get. What we got? Any answers here? What's the top? Well, the bottom we know is 12 now. What's the top? 3m. 3n. N. Okay. Plus. Minus m. Okay. 3n minus m.
Sister Audrey,
Okay. Yep.
doesn't matter what order it is.
So can it be
Negative n plus 3n.
plus 3n? Is that okay? what type of evidence can you support these being okay, the same answer, and they're okay?
Because it's negative n and the positive 3 just flip
Yeah,
down.
so whenever we're asking ourselves, is this okay with all these variables, we just do this? Well, it's the same rules for numbers. So if I did positive 3 minus 2, is the same thing if I just switch the order. Negative 2 plus 3. Are those the same thing?
Yeah.
Yeah. Negative 3 minus 2 and negative 2 plus 3, they both equal 1. That was called commutative property. X plus y the same as y plus x, doesn't matter which way we order we add, it's the same thing. So yeah, and this is good to note that if you guys come in tomorrow and one of you has, an answer like this, another one has this, that you don't argue over right and wrong, you just say they're both correct. The one on the left would be correct because, well, it starts off with n, so it makes sense that our answer starts off with n. So we start with 5n minus 2n, and then I go back here and do the negative n. But this one kind of makes sense because you guys know in a lot of our answers, we always try to write the variables alphabetically. And for n, this would make no sense. But really, they're both correct. And we have to be okay with that in math, that we're beyond the place where it's strictly arithmetic, where there's only one answer, or in algebra and higher math, where you can have different corrections. All right. The important thing is that if I chose any value for n equals 1, and maybe n equals like 3, just pick a random numbers. If I plug it into both of these, I get the same number. That's good. All right, so we're moving to denominators, and make sure that they're always factored. So this is the format you want all your before you start adding, subtracting, you always want to make sure your denominator is a factor, and then once they are, go ahead and work on the numerator, work on the top. Here again, what do we get? 2x minus 9? Plus 9 or minus 9? Minus 9? Okay. Can I factor the top? No. So that's it, huh? Yeah. I always got to check. So after this point, you're going to see the denominators are not factors. They're not simplified. So instead of just starting off with adding the tops, first you want to factor everything. Here we go. So what does the bottom equal? Go ahead and factor it, see what we get. See if you can factor it out. All right, and our GCF is what? What are we using? 4a. Right? Did you do 4 and not the a? Gotta do both. There's an a in both of them. So if you just take out 4 and not the a, that's the problem. So here we go. We get a what? A minus 2. On the top, let's see what we get. 3a
Minus 8.
Okay. Anything factor here?
No.
So can I cancel, wait a minute, 8 and then 4 though? Yeah?
No.
No. A and the A?
No.
No.
Yeah.
No, it's subtraction.
So yeah, followed by subtraction sign, we're not canceling. So you might say, well, didn't you say that if they're multiplying you can cancel, and this is 3 times A, and this is 4 times A, so they are both multiplying, but the multiplication has to be on both sides. So 4 times A minus 1, 3 times A minus 8. Because it's minus 8. If it's times 8, then yes, it will cancel. Okay. Factor, can that denominator factor? GCF? No. 1, negative 815? No. They don't all have the same variable, so no GCF. But this is a quadratic. So you two numbers multiply to 15 and add to negative 8. Absolutely. So we got to do that. Gotta do that. So GCF is usually our go-to, but we have, if you see this quadratic equation, you know, the A, B, C, like you throw in the quadratic formula, that's your cue to throw it, try to factor it. Try to factor it. So we got, what are the numbers, by the way?
5, 3. Negative.
5 and 3. Because if we have the wrong signs, then maybe things would cancel that shouldn't cancel, or vice versa. So yeah, signs are very important right there. What about the top?
6x minus 5.
6x minus 5.
Yeah.
We all agree on that? And so I can cancel what, the 5s?
No, nothing.
The x's?
Nope.
No, gotcha. No multiplication on the top here. I just have a subtraction. So all in the opposite direction, no way to cancel. Good. Rolling right down. I'm going to do a few more. What we got here? Bottom's already factored. That's nice. The top. 2 minus 4 is negative 2. Right? What is it? 6. Why is that? Alright, so 2 minus negative 4.
Oh.
It's 2x plus.
Wait, isn't it
X
negative and a negative 2 is a
minus
positive?
x 0. So when you see this subtraction sign, just like on the front, these are the kind of things that will mess you up. Without attention to detail. Without attention to detail.
Wait, how is it?
Alright, so we got 6. 6.
How do you do it?
So we got 1
Oh, we're adding that
over
one.
x
Oh, I get it.
plus. There you go.
Okay.
Good. Okay. Doesn't that make a difference? Have that thing. 2 minus 4, 2 minus a 8. Good. Take down west. So what does the top equal here? Try it on your own. Get numerator of 25. Be very careful. I got a negative r and minus 6. What you got? This is the correct answer on top. So if you didn't get that, look back at yours and see if you can find it on your own. Somebody to tell you you want to get good at finding your own mistakes and not just having it pointed out. Nobody can do that for you on a quiz and a test, right? So you want to get used to scanning and finding. What is it that you missed? Make a mental note, so on the next problem we don't do that.
R minus 6, R minus 2.
That's correct. Check. See if you can find it. So Let's see, what do we get here on the denominator? Our plus 6 or minus 6? Plus 6. And then our,
Minus.
is that it?
Yeah.
So we can't cancel this, right? They're almost the same, but not quite. Is there GCF on top of all?
No. And 1.
A negative. They both have a negative in common. They got a negative. So yes, that's one of those, that's the last thing. Doesn't happen too often, but a negative counts as part of the GCF. You're always looking for 2s and 3s and variables, but sometimes if they all just have a negative sign, taking that out will help. So if we do this, look what happens. Alright, and yes, now we do have some canceling. So a good eye will say those tops and this right here and this are almost the same. Is there something I can do to one or the other so that they are the same? If they're that close, maybe I'm just one step away from canceling. Start getting creative. Start using all the different tricks that you know. Maybe they do. Or maybe they just look really close and they can't. But kind of take the hint. They're almost the same. Maybe they are. You just have to do one more step. Okay. So we got our minus 2. Good? Okay, try 27 on your own. See what you get. Alright. So I'm going to always start by factoring this. And we're left with minus 3 on the top. We'll end up with negative 8. Anything cancel?
8 and 6.
Yeah. Does 8 over 6 reduce?
Yeah. I like
So
2.
did you stop or did you keep going? Yeah, you gotta keep going. Well, good. That's good. You want to realize all this stuff now, so when you guys do the other ones later, you don't keep making the same mistake. All right, you gotta reduce that. Ends up equaling, let's see. They both have a factor of 2. Okay, so it's the top is 2 times 4. The bottom is 2 times 3. Okay, that's 2 times 3. And then the 2's cancel out. And we're left with negative 4. 3 times e multiplied. Yeah, I will warn you that this is one of the easiest, hardest chapters there is. It's the same rules as the 5th grade, add, subtract, and fractions, but it's so detail oriented. Pretty much anybody that brings a test up with a half hour left, right? They haven't checked anything. They usually have a C or lower. Usually lower. They just wrote something. They probably have this answer, right? And they probably have this answer, and in fact are a negative. And they probably have, you know, they get lucky and they come across one that doesn't reduce, so they'll get something 100% correct, only because it doesn't reduce in the first place. But anything that requires additional reducing, they miss it all, and they end up with this really low grade where they were so confident because they thought it was so easy. So my warning to you now is not to be overconfident. Not to act like you never made a mistake, therefore you're not going to do it on here and it's going to be so easy. Once you finish something, look very close as, well, did I distribute that negative correctly? On my final answer, if I see an even number on the top and bottom, should I be canceling that? You know, sometimes if this was like a p minus 8, no, you wouldn't be canceling. But when it's by itself, yeah, you do cancel it. So are you mixing up any rules of when you're supposed to cancel, when you're not supposed to cancel? So that's the purpose of all these problems practicing this, is that we get good at recognizing when you're supposed to do what. Tomorrow these are not going to be the same denominator. We're going to be multiplying top and bottom by like trying to get the common denominator. It's going to be a lot of work. But we can't be worried about and focusing on consider canceling this or not? You want to get that out of the way tonight. And again, when you come in tomorrow, I urge you to get out your homework. Start checking with people around you to see if you got the same answer. You might be surprised that there's going to be a lot of different answers. A lot of people are going to think this was easy and they got everything right. And you come tomorrow, everybody's got a different answer. So know that the first time through is just the beginning. Okay? Just the beginning. All right, you guys going to do the rest for homework? Finish that up.